One single date, March 25th. This one day acts like a thread, weaving together three totally remarkable stories about order, discovery, and grit. Let's start with the story that affects every single one of us, every single day. Okay, story number one. The man who fixed time. And this is all about a huge problem that everyone on Earth had to deal with. How do we keep our calendar from drifting away from the actual seasons? I mean, have you ever really thought about this? We all learn about the leap day every 4 years, but why did the year 1900 skip it? And why is 2100 going to skip it too? You know, this isn't some random glitch in the system. It's actually a brilliant fix to a very, very old problem.
And the whole story starts right here, on March 25th, 1538, with the birth of a man named Christopher Clavius. He was a German Jesuit astronomer and mathematician who got a massive job from Pope Gregory XIII, fix the calendar, which was slowly but surely falling apart.
So Clavius' solution was basically a three-part master plan. First, he nailed down the problem. The calendar was drifting, no good. His proposal to fix it was radical. He said, let's just skip 11 days. And they did. In 1582, people literally went to bed on October 4th and woke up the next morning on October 15th. And finally, to stop it from happening again, he made a new, much smarter rule for leap years. It's why 2000 was a leap year, but 1900 wasn't. Just an incredibly elegant piece of math.
Just think about that for a second. To get our calendar back in sync with the universe, they had to literally steal 11 days from history. And you can imagine, people were not happy. There were riots. So many people thought the government had robbed them of 11 days of their lives. Okay, we are sticking with the same date, March 25th. But now we're going to jump forward 143 years from when Clavius was born. We're moving from the problem of how to order our time to the challenge of how to order the very nature of change. And that brings us to our second story, the equation pioneer. So we've seen how math put our calendar in order. Now we're going to see how it gave us a language to describe the changing world itself. I mean, really think about this. Everything around us is constantly in motion, right? Everything is changing. A cup of coffee gets cold, a population grows, a satellite zips around the Earth. How on earth do you capture a dynamic process like that with a static language of mathematics? Well, the answer started to come together thanks to this guy, Gabriele Manfredi, an Italian mathematician who was born on, yep, you guessed it, March 25th, 1681. He was one of the very first pioneers in a brand new, revolutionary field of math. And that field is the study of differential equations. Now, that might sound super complicated, but here's the basic idea. These equations aren't about what things are at a single moment. They're about how things are changing. They are quite literally the mathematical language of change. And they are absolutely crucial to all of modern science and engineering. But here's what made Manfredi so important. He didn't just solve a few problems. See, while brilliant people like Newton and Leibniz were inventing the tools of calculus, all their knowledge was scattered in letters and notes. So in 1707, Manfredi gathered everything he could find and wrote the world's very first textbook on the subject. He basically created the instruction manual for the language of change. So you see, he didn't just tinker with a few equations. He organized and systematized an entire field of study. His book became the essential toolkit that generations of scientists and engineers would use to understand and literally build the world we live in today. All right, we're sticking with March 25th, but get ready for a huge leap forward, all the way into the 20th century. Our focus is going to shift now from ordering time and equations to a deeply human challenge, the fight to break down barriers. This last story isn't just about numbers. It's about being number one, as in being the very, very first. No, seriously, think about that. What does that actually take? To be the one to push open a door that has always been closed. To follow your passion in a world that maybe isn't quite ready for you. This brings us to our final, incredible story.
I want you to meet Margaret Barr Moore. She was a brilliant Scottish mathematical physicist, and her life's journey ends on our key date, March 25th, 1975. Her connection to this day is one of legacy, a day to remember her impact.
Her journey was just one milestone after another. Get this, she earned a doctorate in science way back in 1914, which was an unbelievable achievement for a woman at the time. Then, in 1925, she became a true trailblazer. She was appointed as what we believe is the very first female university math lecturer in the entire country of Australia. But her story is also one of struggle. She lost that job during the Great Depression, which is just a tough reminder of how shaky the ground was, even for the most brilliant pioneers. So her legacy, you see, it isn't just in her physics research. It's in her courage. The courage it took to get that degree, to cross the entire world for a job, and to be the first one in the room, to prove to everyone that it was possible.
So let's step back. We've got a calendar fixer, an equation organizer, and a social trailblazer. They seem so different. So what's the deep connection? Let's tie it all together.
When you lay it out across 4 centuries, it's pretty amazing. March 25th marks a birth that gave structure to our time, then a birth that gave structure to the math of change, and finally, a death that honors a life spent challenging the structure of society.
When you really look closer, you see they were all on the same fundamental quest. They were all searching for clarity, for patterns, for a better and more understandable sense of order. One looked for it in the stars, one found it in the language of equations, and one fought for it in the human world of our institutions.
And that leaves us with one last thought, doesn't it? If a single, seemingly random date can connect these incredible stories of human progress, what other invisible threads, what other hidden patterns are weaving together the world all around us right now, just waiting for us to notice them?